Hey, hello, welcome to our video. In this video we're gonna talk about the UPAC system, the UPAC organization, what it does, what it is, the importance in life and chemistry, and also some topics about it that comes from it. So let's start about telling or defining UPAC. Well, UPAC is indeed an organization, which means the International of Pure and Applied Chemistry. And, and what it is an international federation of national academic organizations that represent countries from all over the world. So UPAC is an organization that is composed of all over the world, of people from all over the world. Okay, so and what does it does? Why is important, or what does UPAC does? Okay, so UPAC basically names organic and inorganic compounds. Um, is basically one of many tasks they have, but it's the most important one because it's the one that has made more impact in our world. And then why is it important? Why we need them, or why the UPAC system is very important in our daily life? Well, it's easy. One of the most important things that the UPAC system has become one of the most important topics in, especially in the branch of chemistry, is because chemists from all over the world need one language, um, so they can name the compounds and then not getting confused. Because imagine if there were no UPAC system, Chinese, Americans, um, French, English, all these guys will have their own system, and it will be more complicated to will be more complicated to express or transfer the new compounds to each one to another. So the UPAC system is basically just made for that. And about that, some hydrocarbons that are most common in daily life would be methane, ethene, propane, and propene. Okay, now we're gonna talk about what are hydrocarbons and their classification. First, hydrocarbons are the simplest organic compounds. They are composed of hydrogen and carbon. They can be either straight chain, branch chain, or cyclic molecules. They are divided in two categories, which then it divides into three topics. The first category is called the saturated hydrocarbons, and inside it the alkanes came from. What are the alkanes? Alkanes, well, are the single bond hydrocarbons. And then in another category, the unsaturated hydrocarbons, there can be found alkanes and alkynes. Alkanes are hydrocarbons that have a double bond on its molecule, and alkynes have a triple bond in his molecule.
Now we're going to talk about alkanes. Alkanes are the simplest type of hydrocarbon because they contain single bonds. They belong to the group of saturated hydrocarbons because they contain the maximum hydrogen atoms they can contain. They have a common use as fuels, and their general formula is CnH2n plus 2. Their hybridization is sp3. Some examples are methane, ethane, propane. We can identify alkanes by the prefix -ane. Yeah. Naming alkanes using the UPAC system. First, we need to select the parent chain, which is the longest chain of carbon atoms. It is continuous. Then we need to identify the substituent or alkyl groups. The third step is to number the carbon atoms starting from the end near a substituent. The fourth step is to give the location and name in alphabetical order. Put in position/name. The fifth step is to name the parent chain next to alkyl group with the ending "n." meth, eth, prop, bot, pent, ex, ept, oct, non, dec.
Yeah.
Okay, so here we have an example. First, we need to select the parent chain. This is my parent chain because it contains the large number of carbon atoms. Then we need to identify the substituent or alkyl groups, which are the carbons or hydrogens outside my parent chain. So this is my alkyl group. This alkyl group name is methyl. Then we need to number the carbon atoms starting from the end near a substituent. We're going to start from here because our methyl group is near to this end. So we start 1, 2, 3, 4, 5, 6, 7. This tells us that this means that my hydrocarbon contains 7 carbons. Then we need to give the location and name in alphabetical order. Put in position and name. So we know that our alkyl group is in the carbon number 3. So we put 3 dash our alkyl group, methyl. Then we need to name the parent chain next to alkyl group with the ending -ane. We know that we have 7 atoms, so that means that we're going to use the prefix -ept. So we put it next to our alkyl group, -ept, and we add the -ane, -eptane. So this hydrocarbon's name is 3-methyleptane. Here we have another examples, which we already have the answer, but first we selected the parent chain, we number the atoms, we identify the alkyl groups. In this case, we have 2 alkyl groups, which are methyl, so this means that we're going to add the suffix -d before adding the alkyl name. In this example, we too have the parent chain, we numbered it, we selected the alkyl groups, but in this case, we have 3 methyls and 1 ethyl. One rule is to always start by alphabetical order, so in this case, we have to put the location of this alkyl group first, 3 ethyl, then the 2, 4, 5, which is the location of our methyl group, and since we have 3, we're going to add the suffix 3, and then methyl octane because it contains 8 carbons. Or it can be the other way around, in which they give you the name and you need to draw the structural formula. In these cases, you already know that this tells you how many carbons your hydrocarbon contains, and the end in which, if it has a single bond, double bond, or triple bond. We know that these two gives us the position and the name. And this tells you how many alkyl groups of that same alkyl group we have.
Now we're going to talk about alkynes. There are a type of hydrocarbons. We have triple bonds that are unsaturated. That means that they have less hydrogens. The hybridization is sp, and examples are ethine, propyne, butane. Look at the ending. The UPAC naming of the alkynes. First, you need to find the longest carbon chain that includes a triple bond between hydrocarbons and name it, okay? Now, you have to number the longest chain starting at the end closest to the triple bond. 3. Label each of the substituents at its corresponding carbon, making sure to use the right prefixes di, tri, and tetra. And give the location and name in alphabetical order, position name. This example, since we have 3 carbons, that is the prefix prop, and we have 1. Now we have the triple bond, so it's propyne, and we don't have substitute, so it's propane. Another example is this one. So since we have 2 carbons, 1 and 2, it is the prefix that is named eth, okay? And so we have triple bond, it's named ethine, such as this.
Carbohydrates are carbon compounds that contain large quantities of hydroxyl groups. The presence of hydroxyl groups allows carbohydrates to interact with the aqueous environment and to participate in hydrogen bonding, both within and between chains. Derivatives of the carbohydrates can contain nitrogens, phosphates, and sulfur compounds. Carbohydrates also can combine with lipids to form glycopides or with protein form glyproteins.
In organic chemistry, functional groups are specific groups of atoms within molecules that are responsible for the characteristic chemical reactions of those molecules.
Compounds are benzenes that contain 6 carbon atoms. Many compounds containing this benzene have fragrant odors. The family of benzene compounds become known as aromatic compounds. Some common examples of these are used to flavor are anisole from anise, estragol from tarragon, and thymol from thyme. There are two possible structure representations of benzene due to the resonance in which the double bonds can form between two different carbon atoms. However, scientists have discovered that benzene's behavior are more like an alkene and not like alkane, because benzene does not undergo addition reactions. Now, I'm gonna name the aromatic compounds. Many compounds containing benzene have been important in chemistry for many years, and still use their common names. Names such as toluene, anil, and phenol are allowed in the UPAC rules. When a benzene ring is substituting C6H5, it's named as a pentyl group. When benzene has only one substituent, the ring is not numbered. When there are two substituents, the benzene ring is numbered to give the lowest numbers to the substance. The common name xylene is used for the isomers of dimethylbenzene. When there are 3 or more substances attached to the benzene ring, they are numbered in direction to give the lowest set of numbers and the name alphabetically.
Now that my fellow Ricardo explained what are aromatic compounds and what are the steps to do one, I'm going to show you 6 examples of aromatic compounds. Well, as I just said, here are the 6 examples of aromatic compounds. We're going to start with the first one. This is an A5-ethyl-1,3-dimethylbenzene. The benzene is this one, is the figure you have, and the ethyl is this one, and the methyls are this one. So we're going to count 1, 2, 3, 4, 5, 6. As you may see, in the 1 and the 3 are the methyls, and in the 5 is the ethyl. Okay, passing to the second one, again, we have to put at the end benzene. As you may see in the number 1, 1, 2, 3, 4, we're going to start counting here, is the ethyl. In the number 1, 2, 3, 4 is the propyl, and that's the name, 1-ethyl 4-propylbenzene. Okay, in the third one, it's really easy because this one is called phenol and this one is called bromine, but we're gonna put it as bromophenol. Okay, here, this one it's called 1, 2, 3, 3-bromine benzene. So this is really easy because we know that in the 1, 2, and 3, it's bromine. So we're just gonna put 3 bromines, 1, 2, 3, and benzene, of course. In the second one, we're gonna put is chlorobromobenzene. So as you may know, it's chlorine and bromine, and we're gonna put it like this, chlorine, bromine, and here. And the last one is 1-bromo-4-chlorobenzene. In the number 1 is bromine, and 1, 2, 3, 4 is chlorine. So it's really easy because it's 1-bromo-4-chlorobenzene. Hope this works for you because it's really easy. Thank you.